ICMP as a protocol is extremely handy for testing connectivity. The protocol itself is designed with two main types of messages. There are query messages and error messages. In a simple fashion, we use ICMP to test reachability. The ping utility sends an echo request ICMP message to a destination IP address. If the host is alive, it sends back an ICMP echo reply. If the host is not alive on the network, then the request simply times out. The details of ICMP can be found in RFC 792. You know that ICMP headers contain type code information, and these type code fields can be manipulated to coerce devices to reply when they shouldn't. We'll take a look at this usage as an attack vector shortly. You should know that there are several well-known types of attacks that utilize ICMP. These include ICMP Sweep attacks, Traceroute, Firewalk, inverse mapping, OS fingerprinting, ICMP informational message attacks, and ICMP router discovery message attacks. Let's examine a few of these attacks to get a sense for what we'll be dealing with as a security analyst working in an SOC. Reconnaissance and scanning attacks are usually the start of an attack. This makes sense when you consider that most attacks need to gain information about what's out there before they can proceed to exploit system vulnerabilities. An ICMP sweep is an example of a recon attack that aims to discover live hosts on the network. This type of attack can be performed manually, but more often than not, an application such as Nmap is used. In this example, we're issuing a string command to Nmap that instructs the application to scan the entire 192.168.103.0/24 network and return a list of hosts that respond. Using this information, an attacker can begin to create a map of the network. Now, Traceroute can add to an attacker's network discovery. Recall that Traceroute sends an ICMP echo request to a destination IP address with a TTL value initially set to 1. At the first routed hop, the TTL expires, and the router sends an ICMP time exceeded message back to the sender. The router is added to the list of layer 3 hops. The request is then sent again with a new TTL of 2. The next layer 3 device in the path again decrements the TTL, sends an ICMP time exceeded message back to the sender, and the process repeats. Not only does this provide path information to the attacker, but it also provides details about our network topology, which includes IP subnet information. An attacker can simply bounce back to the ICMP sweep of a specific subnet that was learned via Traceroute, and they now have even more devices that they can target for attack in the future. Well, so far we've discussed how ICMP is vulnerable in such a way that its functionality is used by attackers to learn about our network. Another way that ICMP is vulnerable is an attack vector known as OS fingerprinting. Aside from knowing the existence of target devices, an attacker also wants to know the underlying operating system. This affords the opportunity to determine specific attacks that are relevant to that operating system. Using ICMP for remote OS fingerprinting is a stealthy way for an attacker to do just so. This vulnerability exploits the fact that different vendor operating systems handle network traffic differently. For example, I can send a UDP packet with the DF bit set to target a host where the UDP port is closed. The target device will send an ICMP port unreachable message back. Examining the way that this packet is formatted can help determine the type of operating system that sent the reply. For example, looking at the TOS byte, if the value is 0xC0, then it's likely that the target device is running Linux. Other fields that are used in this determination include the IPTTL field as well as the IPID field. Yes, attackers can use ICMP in many ways, from ICMP tunneling to denial of service to distributed denial of service attacks, such as the Smurf attack, which creates a distributed DOS attack on an unsuspecting host. Knowing about how ICMP attacks are formulated and how they're used can help a security analyst to spot these anomalies when analyzing network traffic.